Hello everybody, in this video we are going to talk about how to factor a quadratic expression. Now we in previous videos have already started factoring by grouping, and so we know that that requires 4 terms. So a lot of the problems you're going to see today are going to only have 3 terms. So I'm going to tell you in this video how we can take something that looks like this, make sure it has 4 terms so we can use the same skill set that we use for factoring by grouping. Now in order for us to do that, our expression has to be set up in a certain format. So let me go ahead and point that out first, and then I'll walk you through these steps that are also written down on your notes. And then I'll show you how to actually use these steps to be able to break down a quadratic expression. So the first thing I want to point out, this is what a quadratic standard form looks like. The number in the front is going to be your A, because that's the one that has the x squared. Your B is going to be the number in the middle. It's the one that just has the x. And our C is going to be at the end, and it's going to be the number that has no variable attached to it. So please make sure your expression is set up just like this for us to be able to walk through these steps. So I'm going to remind you that we were using factoring by grouping, and in order to do that we need 4 terms. This one only has 3. 1, 2, 3. So I'm going to show you how to take something that has 3, turn it into 4, so we can then factor by grouping to factor our quadratic expression. So before we get started, let me go ahead and point out a couple things. So step number 1 says to take the A value and the C value and multiply it. So you're going to look at the A, which is the first number, the C, which is the last number, and you're going to multiply them. And that's going to give you a different number. We're going to call that number AC, because we get it by multiplying A and C. Then you're going to list all the factors, all the numbers that multiply to give you that particular number. And we're going to figure out which one of those numbers multiply to give you AC, but combine to give you the B in the middle. Because what we're going to do is we're going to replace the B in the middle with 2 different numbers, or they could be the same number, but 2 numbers that if you multiply them would give you AC, but if you combine them would give you B. So if we were to replace B with 2 different numbers, we would get 4 terms. So we would end up with something that looks like this: ax squared, and then we would take our B and replace it with 2 numbers. So let's say, for example, we'll call that dx plus fx, and then we would bring down our C. And then by doing that, we would end up with not 3 terms, but 4 terms. And if we have 4 terms, then we're able to factor by grouping. Okay? And when we get done factoring by grouping, our answer would look like this. We would have 2 separate parentheses that, if we were to multiply them back, would actually give us our original problem. Okay, so one of the last things I'm going to do before I go into the next examples on our notes is remember that when you do get your 2 parentheses, please check for an extra GCF, because sometimes there's extra numbers that can be factored out even further. So that should always be the last thing that we do, but we should definitely do it before we move on. All right, with that being said, let's go ahead and just quick reminders on how to do find the greatest common factor and simplify that way. I'm going to remind you how to factor by grouping, and then we're going to actually factor quadratic expressions. So let's go ahead and look at the next couple examples. All right, so I'm going to give you a quick reminder on how to find the greatest common factor and how to simplify these smaller expressions. So right here on the top, you're going to see the things that we're going to look for to find the GCF. Number 1, you're going to look at all the numbers in your expression, and you're going to find the biggest number that divides into both of them. Second, if they both have the same variable, not this one because this one has a P and this one doesn't, but if they both have the same variable, you're going to find the smallest exponent and you're going to factor that out. That's going to be part of your greatest common factor. And then the last thing that I do want to remind you, if your leading coefficient, that means the number in the very front of your expression, is negative, we need to factor out that negative when that first term is negative. Now we only do that when the negative is in the front. So it doesn't matter what the second term is, we just want to factor out leading negatives. So I'm also going to remind you that there is a way for you to use your calculator to find the greatest common factor, especially when we're dealing with much bigger numbers. So I'm going to remind you that I am using a TI Nspire. So if you also have a TI Nspire, let me show you how to find the greatest common factor on your calculator. So I'm going to go to my scratch pad. So I'm just going to hit A here. And my numbers are 7 and 14. So I'm going to move over here so I don't show you the glare. And so what you're going to do is you're going to start off with menu, number 2, and then notice that we're going to go to 5 to find the greatest common divider. Okay, your GCD only does 2 numbers at a time, and you do have to separate it with a comma. So if you don't know where your comma is, it is going to be right here underneath the pi symbol and next to the O. So our 2 numbers are 7 and 14, so I'm going to do 7, 14. Okay, I'm going to close it, hit enter, and it tells us that the biggest number that divides into 7 and 14 is 7. So that is going to be our greatest common divider. So I'm going to put a 7 here. I'm going to remind you that this 7 is positive, so when we divide by 7, it is going to be a positive 7. So these need to match. Not in number necessarily, but in sign. So if the first number is positive, your number that you're going to divide by is also positive. All right, because they both don't have p, we cannot divide out a p. We cannot factor out a p. So all we're doing is dividing both of these numbers by 7. So 7 divided by 7 is 1. And bring down the p squared. 14 divided by 7 is 2. And there you go. We are done with the first one. So let's do the same thing with this one, just because this one has a variable that we could factor out, and it also has a negative. So let's find the greatest common factor of 24 and 8. So once again, my numbers are 24 and 8. I'm going to hit menu, 2, 5, and I'm going to do 24, 8. Your calculator does not care if the numbers are positive or negative. We're just looking at the numbers. So if you put a negative 24 in here, it doesn't matter. I'm going to hit enter, and it gives me 8. Now, this is where I'm going to ask you to do something differently. We're going to use the 8 because 8 divides into 24 and 8. But because the 24 in the front is negative, then that means that I need to divide by a negative 8. I'm going to factor out a negative. Second, notice that they both have n's, so this one's n to the 3, n to the second. So between both of these, 2 is smaller. So I'm going to take out n to the second. So we're going to do 2 things here. We're going to take this number and divide both of these numbers. So we're dividing. But we're also going to subtract our exponents. So whatever exponent I have here, I'm going to subtract 2 from it, and I'm going to put what's left over inside my parentheses. So this is a negative 24 divided by negative 8, which is a positive 3. 3 minus 2 gives me 1, so just 1n. All right, let's move on to the second number, which is 8. 8 divided by negative 8 is negative 1. 2 minus 2 is 0, so 0 ends with the negative 1. And there you go. So just a quick reminder on how to find the GCF, because this is going to be the one little piece of the skill that we're going to use over and over and over again. So I'm actually going to pause right here, but the next thing I'm going to do is remind you how to do factoring by grouping, because when we move to the back of these notes, we're going to take an expression with 3 terms and turn it into an expression with 4 terms, so we can continue to factor by grouping all the way through. So I hope that these examples have helped. I know we didn't do a whole lot, but I'll see you guys in the next video.